everyone, welcome back to the channel Code with AKJ. Today is day 8 of solving LeetCode 75 challenge, and today's question is increasing triplet subsequence. So the question says here, given an integer array nums, return true if there exists a triple of indices I, j, k such that I less than j less than k and nums of I is less than nums of j is less than nums of k. And if no such indices exist, return false. So in today's video, we'll be tackling a popular problem called increasing triplet subsequence. So we'll look at a brute force solution first and then dive into an optimal solution with better type complexity. So let's get started. So here the problem gives us an array of integers nums and we need to find if there exists an increasing triplet subsequence in the array. Specifically, we are looking for three indices I, j, k such that I less than j less than k and nums of I is less than nums of j less than nums of k. So if such a triplet exists, we need to return true, otherwise we need to return false here. So let's first go over the brute force approach. The simplest way to solve this is by using three nested loops to check each and every possible triplet in the given array. So we'll start with the outer loop running for the index I, then the middle loop for index j, which should be greater than index I, and finally the innermost loop for k, which is greater than both I and j. So for each combination, we check if nums of I is less than nums of j is less than nums of k. So if we find any such triplet, we can return true immediately. And if we complete the loops without finding any valid triplet, we'll return false. So this is the code for the brute force approach we have discussed. Here I have taken the size of a nums vector. I have taken three for loops, each for loop for each index I, j and k, which should be greater than each other, where I is less than j, j is less than k, and for using these three for loops, we'll check this particular condition where nums of I should be less than nums of j and nums of j should be less than nums of. So if we found any such triplet which satisfies these two conditions, we'll return true from there. And after finishing these three for loops, if we didn't found any such triplet satisfying these two conditions, we'll return false. So let's dry run this with this example 1, 2, 3, 4, 5. I have taken vector of array 1, 2, 3, 4, 5 where I starts from 0, j starts from I plus 1 and k starts from j plus 1, satisfying this particular condition, first condition. And here our second condition would be nums of I should be less than nums of j should be less than nums of k. So while using these three for loops, we'll check whether this particular condition is being satisfied or not. So if we found such triplet in this given array, we'll try to return true, or if not, we'll return false. So considering the first iteration here, since nums of I is 1 and nums of j is 2, nums of k is 3, and since 1 is less than 2, 2 is less than 3, so it's satisfying these two conditions, hence we can return true from the first iteration itself. So for this particular vector array, our answer would be true. And here the time complexity would be O of nq, as we are using three nested loops, and space complexity would be O of 1, as we are not using any data structure here. So let's try to run this code. So again, so let's submit. As you can see, this approach gives us time limit exceeded because of O of n cube time complexity. So now let's discuss a much better approach with a time complexity of O of n, which will be more efficient for larger inputs. So here's the key insight. Instead of checking every possible triplet, we can keep track of two variables, which is smaller and second smaller, as we encounter through iterating our array. So here will be the particular step. So from the given array 1, 2, 3, 4, 5, so we initialize first and second to very large values, that is int max initially. So as we go through these numbers in this array, so if the current number is smaller than or equal to the first, we'll update the first to that particular number. Or else if the current number is smaller than or equal to the second, we'll update the second variable. So but if the current number is greater than both first and second, then we found a triplet that satisfies our condition. So we can return true here itself. So here in optimal approach, we'll take both variables first and second, which would be initially a very large number. So we'll assign it with int max, which is the largest value in integer. So as we iterate over this particular array 1, 2, 3, 4, 5, we'll check whether if this current number is smaller than or equal to our first variable or not. So since 1 is less than int max, we'll update our first variable with 1. And second, we'll move to the second number. So we'll check if the current number is smaller than or equal to second or not. So since 2 is less than int max, we'll update our second variable with 2. After moving on to the next index, we'll check if this current number is greater than both first and second or not. So since 3 is greater than 1 and 2, so here we found a triplet and we can return true from here itself. So in this case, our time complexity would be O of n as we are iterating over the array only once, and space complexity would be O of 1 as we are not using any extra data structure here. So let's move on to the code and let's submit. So this is the code for the optimal approach we have discussed, and try run with this particular example 1, 2, 3, 4, 5 array. So here I have taken two variables first and second, which would be initially int max, and here I have used for each loop while iterating over this nums vector. And if the current number is less than first, we'll update the first variable, and if the current number is less than second, we'll update the second variable, and if the current number is both greater than first and second, we have found our triplet, so we'll return true from there. And after iterating our whole array and we didn't found any such triplet satisfying these two conditions, we'll return false from the main function. So let's try to run this code. So let's submit. As you can see, this approach is successfully submitted. So here the time complexity is O of n as we are iterating over the array once, and space complexity is constant, which is O of 1. So there are some edge cases to consider, including like array with size less than 3 elements. So if the array contains values only 1 and 2, we should return false in this case as we need a triplet. So in this case, a triplet cannot exist, so we'll return false in this. So this would be one of our edge case. Second edge case would be with the array with all elements with same values, that is duplicate elements. So for example, the values 1, 1, 1, 1 and 1. So here the size is greater than 3, but the elements are of same value. So in this case, we can't find any triplet which satisfies this first condition, which is I less than j less than k. So that's why in this case also we need to return false. So along with our approach, we need to handle these two edge cases as well to make sure our code works properly for each and every cases. So that's it for today's problem. We have explored two solutions, a brute force method using three nested loops and an optimal solution with a single pass and a constant space. So this optimal approach is crucial for handling large input size efficiently. So if you found this video helpful, don't forget to like and subscribe for more coding tutorials. Also let me know in the comments if there are other problems you'd like me to cover in this series. So thanks for watching, and I'll see you in the next one.